Alright, now we're going to make our little transfer punch. I've got the compound set on 50 degrees. That'll give us a good steep 100-degree included angle when we make this out. We're going to I'll quickly show you, give you an idea of what I'm looking to build here. This is obviously not the scale, but it'll be 350 thousandths long, set down in the hole, and with just the tip sticking out, and that way we can transfer that hole center to the to our top plate. Diameter will be 425 thousandths. We're going to put that angle on there first. Like I say, it'll be a 100-degree included angle. I've got the camera backed up a little bit, so anyone that's maybe not familiar with the compound, I have the carriage locked down now. I'll be using the cross slide to advance in, but the compound to actually cut the angle. And I'm moving in about 50 thousandths at a time. I left the diameter, the full width of this piece I found in my scrap bin over there, just so it'll be a little more rigid. I'm actually cutting in both directions. And this should give us a point on the end now. Alright, now we'll get that compound swung back around, which I normally have it set at 30 degrees in the other direction. It really doesn't matter. That just gives a good location for, seems to be a good center point, in between point, getting out of the way of the compound. I'm sorry, getting out of the way of the tailstock. Now while we got that loose, I'm going to go ahead and set that to so that it's perpendicular to the chuck. Just using a 1, 2, 3 block. Now be sure my carriage stop is, it's set where I shouldn't run into the chuck, shouldn't have any crash. We'll get a small cut now, and then get a measurement and see how much we need to take off total. I'm cutting this considerably longer than it needs to be, just so I've got plenty ample room there. We got a lot to go, like it's obvious. That's 675. And we want 425. So that's 250 thousandths we want to take off. I'll zero out my DRO. And we'll take about 50 thousandths at a time off the diameter. Alright, that was 200 thousandths, so I'm going to get 25 more approximately 25 more, and then we'll take a measurement. That's 450 thousandths, so it's coming out just right. So we'll go to 250 thousandths on the DRO. I just don't want it too big because it's got to go down in that hole. That's about 6 thousandths over. I didn't think I'd set it right the last time, so. All right, that's 423 thousandths. That's good. That gives a little bit of clearance there. Now, we want to part this off, and if any part is measurement is crucial, this one probably is. All right, I've got the cutoff tool bumped right up to it. I'm going to zero out the Z. We want total length to be 350 thousandths. So I'm going to come to 350. And then 100 thousandths for the thickness of the blade. All right. Slow our RPMs down, and we'll part it off. Okay, I stepped over to get my cup with a little bit of water in it just to catch this piece, and then I can cool it off enough to hold it up and show you what we're actually making here. Okay, there's what we were making. This will set down in the screw hole with just the tip sticking out is the plan. That way we can transfer that hole to our top plate we made. That little tip that was left on there from the parting tool, don't even need to worry about sanding that off. That can go down in the hole, in the actual screw hole itself. This will be riding on the shoulder of the counter bore. So get the camera turned around, I'll show you what I'll be doing. I think maybe I got you close enough now that you can see. Here's a little piece we made. I've got the cap head, socket head cap screw out of this hole. I'm gonna drop that in there, and it is just barely sticking up. We'll put our plate on there and give this a good tap, and hopefully that transferred that hole. Sure did. Got a good transfer. Hopefully you can see it right here. Now I'm going to drill and counterbore that hole and continue that process one at a time around the round all four. Now I'll give you a little secret. See who's paying attention to all the videos. This is the second one of these I made. The first one I made, I had the intention of getting it out with a magnet. I did not even notice that the material I got out of my scrap bin over there to make that first one out of was stainless steel. I dropped it down in that hole, and of course stainless steel is not magnetic. I had the dickens getting it out of that hole, but works so much easier when you use the right material. Okay, I got all the holes located, transferred over and indicated onto the gearbox plate. Got them counterbored. I went to, well, one other thing I did while I had it out, I eased these front corners right here, put a little radius on those. And I went looking some socket head cap screws in metric to fit this, but finding metric screws around my neck of the woods on a Saturday, other than very common sizes, is kind of like finding chicken teeth. So it's not quite ready to mount yet anyhow, but it's from this plate right here that we'll continue to build our structure on up for the power drawbar. Everything will be mounted to this plate that we just built. All right, now that we have our gearbox plate finished, mounted on there, the next step we want to do, building this basically from the ground up, we need a circular plate up here, or platform, that all of our sliding mechanism is going to work on, and also our impact wrench will set up here. Excuse me. Now, as you can see, I got very little clearance right here, and I don't like modifying the stock equipment if I don't have to, but I just don't have enough room right here. So what I'm going to do, I'm going to take the Dremel and cut these little fins right here off. There's just not enough clearance there to get an upright up here. I've got an extension on the air wrench right now, but the air wrench would actually be sitting down in this area. Again, you can't really tell right now because of the all right. We got clearance issues at the top as well up here, since the air hookup comes off of here. We've got several challenges to have to work through on this, but I don't think any of them is going to be insurmountable. We just got to take our time and plan it out well in advance. But again, these fins are going to have to come off right here, so that we can have a plate big enough to mount our slide mechanism on. There'll be a 2-post up here that our slide here will work up and down on. So I'll drop the camera back down. Like I say, I'll be taking these fins off of here, but I'm going to slide the camera back down now and give you a little bit of a drawing of what we're going to actually be trying to cut out here. Maybe that will show up on here. I want my platform to be 4.5 inches wide. This is the center of the drawbar right here. I'm hoping you can see that okay. All right, this is the center of the drawbar. If I take those fins off, I'll be back at 1.4 inches. If I don't take the fins off, 1 inch is all the clearance I've got. This hole here has got to be approximately 1 inch for the socket to pass through, and the drawbar to come up through if necessary. So again, gonna make a circle 4.5 inches wide, but we're gonna clip off at 1.4 inches from the center right here. So what I've got in the mill right now, I've got a piece of material. I'm gonna have to it's got 2 good edges on it now. Well, it's got 1 good edge on the back and a fair edge here, but we're going to see if I can find a little piece of copper wire here, and we'll see if this will stay down. Looks like it. Yep, it's going to want to ride up. Let me Well, that had a chip under it. That might have been what it was trying to ride up. Yep. All right. That should have it down now. For proof of concept, I'm going to handheld hold this by hand. Let me get the camera back here so maybe you can see what I'm actually doing. All right, I've got the camera backed out a little bit. I had to get some more length on my microphone cable and power cable to the camera. But hopefully you can see what I'm doing here. For proof of concept, I have my mill, roughing end mill, my 3/8 collet, and I have the with the extension, and it's just going to be handheld right now. And my roughing end mill, and I have the socket on the extension now on the impact wrench. I'll set that up there. Find my notch. Alright, that's in there now. And that is tight. Alright, so I'll leave that like that and see. I'll swing the camera back around to the filming position and we'll see if that tightened it up enough. Alright, as I say, this is a factory edge right here. But I want to clean that up just enough. It's just got a little dings from where it's been tossed around in the parts bin and so forth. So I want to just touch that off enough. Also, I think I've got a good grip on it there. But we don't want to put too much pressure on it until we can get a butter bite on it. I'll move in just a little bit, tighten my X down. And I need to go down a little bit more on the Z. All right, that cleaned that edge up good. Now let's come over and we'll get the one of our corresponding or one of our perpendicular edges. I have the circle drawn off on there with a pencil, just to get a close edge. And the only thing I'm wanting to do right here is square this edge off so that I've got two good sides before we turn and cut this 1.4 inches off. This will be the precise cut on this edge right here. Alright, that's all holding pretty good, or real good. Now I could turn this up. I've got the jaws on the outside of the vise now, and I'm debating on whether I want to stand this upright, mill this off, or if I want to just go ahead and put it in this way. I think I'm going to go with this. I've got two flat edges to work with there now that I can get a good grip on. Now we want 1.4 inches from this center. I've got what's going to be the center of the circle. I've already got that laid out. So I'm going to get just as always, just going to get one little skim cut to get a measurement from. I know I've got a little bit to work with here. And I want to go back up on my speed just a little bit. There, I think that's better to cut this aluminum with. Alright, the very spot I need to measure from didn't quite clean up there, so make another pass. I'll turn my DRO on now. Take about 20 thousandths off there. Just enough I know it'll clean up. Alright, I have a 0 set there now. Get my calipers and measure from the little witness indentation I have right there. That is 1.52, so we need to take 120 thousandths off. 1.52, and we need 1.4, so that's 120 thousandths. I'm going to take I'll take about 65, 66 off here. This piece I'm using for the mountain plate is a piece of 3/8 inch thick aluminum. 1/4 inch would have been fine, but this is what I had. In fact, it's the only piece I had big enough to get this out of. So that's what we're using. Plus, this will work good to counterbore my countersink my heads in, screw heads in. Alright, we set 120 thousandths, so we'll go the remainder. Lock down the X. Alright, when I get this back now, I'm going to carry it back to the workbench, and with the pencil I will, pencil and compass, I'll lay out my approximate circle before we go to the mill. It will be from this center point, lay it out, and then I'm going to go to the bandsaw and take off some of that corner. Take off some of the big parts of the corner, so we won't have quite as much to turn on the lathe. Alright, didn't think to mention it before I took the material out of the mill, but the impact wrench sure tightened the collet enough to cut this aluminum, and I believe it is probably as tight. I may try it with my hand wrench just to see if it feels about the same amount. But I have a piece, got the corners knocked off on the bandsaw, got it in the lathe now, and if you've watched my other videos, you've seen me do this before, maybe not on a piece quite this big, but I have the tailstock tied up against the work now with my live center in the what will be the center hole. I have double-sided tape on the back holding that to keep from twisting. The most force is, of course, coming from the tailstock on that. But we're going to keep working this down until we get back to our line there, and then we'll start measuring. Remember, we're wanting 4¼ inches for the total diameter there. 4½ inches for the total diameter. So let's see how this is going to do. Taking very little amounts at a time right now just to knock some of these corners off. I'm doing this by hand right now, but I think I'm gonna put my feet in a little higher gear and do some of that manually. So just so I don't have my arm right there in front of that. That's throwing some pretty hot chips out. I think those chips are going to find a way in my shirt no matter where I stand. When you're doing something like this, we've almost got it round now. But you do want to periodically check and be sure your tailstock is still plenty tight on it, which it is. Let me take one more cut. I'll reduce my speed back down so I get a little better finish. 4½ inches is what we're looking for. And it is not absolutely critical that it be 4½, and it's just about going to be impossible to get the calipers in there. I need a set of left-handed calipers. I've always wanted a set. That's 4.865, so zero out the X. What did I say? 4.586. Double check. .586. So I need 86 thousandths off the diameter. So on the X, I'll take about 40 on this pass. And there's our 86, and that is right down to our pencil mark, so I'm happy with that. I'm going to back that out, see if I can get just a little chamfer on that. I want to look at those chuck jaws though when I'm doing this. Be sure I don't get in too close. Get that tool out of the way before I go pulling on something. Okay. And that did not slip at all. Stayed right in place. Plenty of friction on there. So we have us a good round piece now. 3/4 moon maybe. All right, I'm going to go over to the workbench and do some more layout on this, and I'll bring the camera over so that you can see what we've got going on.